going on, guys? In this video we are going to see how to solve a non-exact differential equation. Now first of all, we don't know whether an equation is exact or non-exact until we check it. Now let's go ahead and check this one, whether it's an exact equation or non-exact equation. But before we go and do that, you have to know this term is m of x comma y. The term that multiply dx is m of x comma y, and the term multiply y is n of x comma y. In order to be exact, we have to have this m with respect to partial derivative of m with respect to y should be equal to partial derivative of n with respect to x. Now let's go ahead and see what we are going to get if we do that. If we take the derivative of this one with respect to y, this is going to become 2y minus 1. And if we take the derivative of this n with respect to x, this is going to be just 1. Okay. Now from this one we know these two are not equal, so this is non-exact. So if an equation is non-exact, the next thing is we have to find out an integrating factor, and then we have to multiply that integrating factor with this one to make this one exact. Now let's go ahead and see how to find the integrating factor. There are two ways you have to check it. The first one is you have to see my minus nx over n, and when you do that, you have to have x terms alone. If you have a y, you can't use this one, you have to try this one, nx minus my over m, and if you get y alone in this one, you can use this one. Now let's go ahead and see what we get. My minus nx over n. My we calculated, that's 2y minus 1, and nx is 1 plus 1 divided by n. N is this term x. Okay, when we do that, this is going to give us 2y over x. Since we have an y right here, we cannot use this one because it has to have x alone, so we cannot use. Now let's try this one. Here we have to have y alone. Now nx is 1 minus my is 2y minus 1, 2y minus 1 divided by m. M is y square minus y. Now let's see what we get. 1 minus 2y, 1 minus minus, that's going to be plus, plus 1, and then here we are going to have 1 minus 2y plus 1 divided by y square minus y, and then 1 minus 2y, so we can add this 1 with this one, so 2 minus 2y divided by y square minus y. Here we can take 2 common, that's going to give us 1 minus 2y, 1 minus y, and divided by, here we can take y common, y minus 1. Okay, 1 minus y, y minus 1. This is just inverse, like if you take negative common, you can switch it around, so we can cancel this out and put a negative 1, because if you take the negative 1 common, this is gonna turn around, right? Because 1 minus y, if you take negative, what's gonna happen? This will become positive and this will become negative, and you will get this one, and that's how I cancel this one. So from this one we get minus 2 over y. So here we have y alone, so we can use this term to find out the integrating factor. Okay, so we have to check these two. If I check this one and get x alone, we can go ahead and use, I can go ahead and use that, but since I got a y, I cannot use this one. But here we got y alone, so we can use this one and find out the integrating factor. The formula for integrating factor is mu is equal to e power this whole term, nx minus my divided by m. We found out this term already, minus 2 over y. So we have to integrate this one with respect to y. So we already found out e power negative 2 over y integrate this one with respect to y. Now negative 2 is a constant, so we can move that one to the front, and integration of 1 over y is ln of y, and then this minus 2 we can move it right here, so this is going to be just y power minus 2 e power ln y power minus 2, and that will give us 1 over y square, because e and ln cancels each other, so we will get 1 over y square. So this is our integrating factor. Now after we find out the integrating factor, we have to multiply both sides of this equation with the integrating factor. Here when you do the integrating factor, you don't have to worry about the constant, because the constant will cancel anyway, because we are multiplying both sides. But so we don't have to worry about constant in anything. Like even you do the first order linear differential equation, you will notice when we have a constant, we just neglect that one and do the multiplication. So we just have to multiply 1 over y square, and when we do that, this will become just 1 minus y. Okay, let's do the multiplication, not 1 minus y. Let's do it from the beginning. Okay, now y square minus y multiplied by 1 over y square dx plus 1 over y square x dy is equal to 0. Now 1 over y square times y square, that's going to be just 1, minus y over y square, that's going to be 1 over y dx plus 1 over y square times x, that's going to be just x over y square dy. That's equal to 0. Now after we multiply it by the integrating factor, now we have to check again whether this is giving us exact. Now we know that the value that's multiplying dx, that's the m of x comma y, and the value multiplying dy is the n of x comma y. Now we have to take the derivative of m with respect to y, and we have to take the derivative of n with respect to x and see whether these two are equal. And if I take the derivative of m with respect to y, this is a constant, so this is going to be 0. Here 1 over y, if you take the derivative of this one with respect to y, 1 over y is what? Y power minus 1. If you take the derivative, the minus 1 will multiply here. You will get plus, and that will give us, we have to subtract 1 from the power, y power minus 2. So that's going to be equal to 1 over y square. And that's going to become positive because when you take the derivative, there will be a minus multiply here. So 1 over y square will be the answer here. Now let's check this one. Here we are taking the derivative with respect to x. Y is the constant, so 1 over y square remains the same. X is going to become 1. So this will give us 1 over y square. So these two are equal, so this is exact. Now after we multiply by the integrating factor, this became exact. Now we can go ahead and solve this one as we solve exact differential equation usually. Okay. Now let's go ahead and do the exact differential equation method. The first thing is, in exact differential equation, we take a function with derivative of function with respect to x, and we equalize that one to m of x comma y. Make sure you do that to the new one, new derived one, not the old one, right? This is not exact. We have to do it for the new one. That is 1 minus 1 over y. 1 minus 1 over y. This should be minus 1 minus 1 over y. And then here we have, okay, this is for partial derivative of function with respect to x, and also we have to equalize partial derivative of function with respect to y to n of x comma y, that's x over y square. And we keep the one of the term and do the integration for the other term. So here we have to do the integration for this term with respect to x. So f of x comma y, because when we do the integration with respect to x, this derivative will go away. So we will have a function with respect to f of x comma y because it will contain x and y. When we do the integration, this is going to become x, and here we will have minus x over y. And also we have to add a constant. That constant should be a function of y. Since we are doing the integration with respect to x, we have to add a constant with respect, that should be a function of y. Now this is going to be the final solution, but we cannot express like this. We have to find out what is the h of y is. Okay. To find out the h of y, what we have to do is we have to do the derivative of this one with respect to y and compare with this one. Now let's go ahead and do that. F with respect to y. If I take the derivative of this one with respect to y, this is going to become, this is a constant, so this is going to become 0. And here we have x over y. This x will become, okay, we are doing the derivative with respect to y, so this is y power minus 1, minus minus multiply and cancels each other, and this is going to become y power minus 2, right? So we will have x over y square, and also this will become h prime of y. Now if you compare this one with this one looks similar, this one is the same, but here we have h prime of y, but we don't have anything here. It means h prime of y is equal to 0. Okay. Now if h prime of y is equal to 0, we have to find out what is h of y. That's our purpose. Now to find out the h of y, we have to integrate this one with respect to y. With respect to y, we have to do the same thing other side. Integrate with respect to y. when we do the integration of this one with respect to y, integration and derivative cancels each other, that's going to become h of y. And here if we integrate a 0, that's going to become a constant. Okay, now we found out this is a constant. Now this is going to be our solution. So we can say f of x comma y is equal to x minus x over y, and instead of this h of y we add this constant. Now finally we have to equate the whole thing to 0. 0 is equal to x minus x over y plus constant, and this is going to be the solution for this exact differential equation. I hope this helps, and don't forget to subscribe. There are a bunch of videos on differential equation in my playlist. I hope you guys watch that too, and see you next time.